Hey, it's Horner, and this is the Virtual Momentum and Collisions Lab using Physics Classroom. So you'll click on the link to open both the physics simulation from Physics Classroom. This is what it looks like. And you also will need the spreadsheet. And yes, it looks like a lot, but it's really not that bad. You'll see that the simulation, you can make this bigger and smaller depending on what you do here. So if it's really small and you can't see it, easiest thing to do is grab that little draggable down in the bottom right and drag it so that you can see it. You want to set up the initial conditions. So the initial conditions are the left cart should be 1 kilogram. So there's a 1 kilogram, there's a 2 kilogram, and a 3 kilogram cart. We're just adding mass to the 1 kilogram cart to make it heavier. And it's going at 3 meters per second positive. You can't use the slider to drag, but you can use the button, so we're going to make this 3. The next thing we need to do is fix the right cart. It's 1 kilogram and 0 meters per second, so we're going to make this 0 meters per second using the buttons. And the collision type is elastic, so you're going to see elastic, inelastic, and explosion. And I will tell you that these terms aren't 100% correct. We're going to correct them. But if it says elastic, click on the elastic button. So it's more of a direction than anything else. Next thing you'll do is you'll actually start the simulation. So we're going to start it, and you're going to see the left car is moving towards the right car, and then it hits it, and then the right car moves. So we've got before and after the collision. Everything before the collision is outlined in red. Everything after the collision is outlined in blue. So when you start, what you'll want to do is, it says, first off, what is the left car velocity? And that's before the collision. So remember, we started with a velocity of 3 meters per second. So we're going to put that in. That's positive. The left car direction of velocity, it was moving towards the right. So we'll put that in. The left car momentum now is going to be the mass of the car times the velocity. So the mass was 1, velocity is 3, so that one's really easy. That one is now just 3. The left car direction momentum is the same as the direction of velocity, so it is right. Our right car velocity before the collision was 0. So we're going to put 0 in. The right car direction of velocity is nothing. So you're just going to leave it blank. The right car momentum is 0 because 1 times 0 is 0. And the direction of the momentum is nothing. So we're just going to leave it. The total momentum of the two cars together. So you'll see that the left car momentum was 3. The right car momentum was 0. You add those two together, and we get 3. The next thing they want is the total momentum direction. And that one is going to be to the right because that is our total momentum. So if it's positive, it's to the right. The left car kinetic energy. So this is where you're going to make sure that you remember that kinetic energy is 1/2 mv squared. So our left car kinetic energy has to be 1/2 of 1 times 3 squared. So 3 squared is 9. 9 times 1/2 is going to be 4.5. So our left car kinetic energy is 4.5. Our right car kinetic energy, because it is never moving beforehand, is 0. And now I'm going to add the two together, and that gives me my total kinetic energy, which is 4.5. So now I am done with the before. I've got to go down and fill in the after the collision now. So for this one, the left car velocity after the collision is 0. The direction of velocity, there isn't any. The left car direct momentum then is also 0, and there is no direction because it's not moving. The right car velocity is 3, and the direction is right. The right car momentum is going to be 3 times 1 because we have 3 meters per second times 1 kilogram, so that is 3. And the direction of the momentum is also to the right. If I add the momentum of the left car and the right car, 0 plus 3 is 3. And because that's positive, the direction of the momentum here is going to be to the right. The left car kinetic energy. So this is after the collision. And remember, this one's going to be 0 because it's not moving after the collision. But after the collision, the right car kinetic energy is going to be 1/2 of the mass. So a half times 1 is a half, times the velocity of that car squared. So 3 squared is 9 times a half is going to give me 4.5 again. So that's 4.5. And so now the total kinetic energy, add the left and right car, is going to be 4.5 joules. That is basically how you go through and do the math. There is other types of collisions. You're going to see this one is inelastic. And then we have explosion. So they want to know, do the cars bounce, do they stick, or do they explode? So if they bounce off of each other, you're going to put bounce. If they stick together, so let's go to inelastic collision. Let's run the same thing again and see what happens. And if I start this and they move towards each other, then when the left car hits the right car, they stick together. So we call that a stick. That is when you put in the inelastic in the program, it's that way. It's not always going to happen that way, but this is going to be a stick. So you'll notice that's the one I just did. The last one is an explosion. And when you do explosion, you're going to notice both cars are going to be together. Notice they both have a mass of 1 and they both have 0 initial velocity. And then when you start it, and it goes, you'll see that this one's -10 and this one's +10 in the end. So that is the explosion, and that one we can just term explode. Okay? So other than that, you should be good. That won't change down here, so whatever you put up here is going to be the same for after the collision, and you should be good. The last thing that you'll have to do is go in and fill in the actual report sheet itself, and the report sheet looks like this. It wants you to copy and paste your red data in the table below, red data table below. So you're literally going to go in, grab everything that's red, copy it, and then you're going to paste it into this spot. You'll do the same thing with all your blue data, and then you're going to tell the different types of collision, the momentum before, momentum after, the percent difference, the kinetic energy before, kinetic energy after, and the percent difference for kinetic energy. So it will take you a little while to do the lab. That's why you don't have much to do other than this, and that is it.